Hello, it's Zaman and welcome back. I'm really happy to be here with another great tutorial, and it is about C# exceptions like a senior. You will not just learn C# exceptions, but also dive into details of C# exceptions like a senior. In our agenda, we have what are exceptions, why use exceptions, try catch finally, try finally, the multiple usage of catch, custom exceptions, how to create custom exceptions, why to create custom exceptions, best practices, and when not to use exceptions. This is the only tutorial you need to watch and master C# exceptions, so it is enough talk. Let's get started. First, let's try to understand what is exception and why exceptions, okay? When we develop our application, when we design our classes, modules, our methods, we'll always first strive to happy path. We'll always strive to success. And it means when we design our stuff, we are testing, we are designing our algorithm in our mind with a success path. But unfortunately, it is not always possible for us to be successful from the first design. For example, let me show you one simple stuff here. Let's say I have simple list. Okay, and I have two data here. When I try to retrieve the first indexed value here, the first, I know that it will work, and say this is my data structure designed by me, and I know that it will work. So let's run it. So you see, I have designed my application for success path, but we always design our application for our customers, for our company, and they don't know the internals of our application, and they may use our application within the provided data. It means my list is able to get integer index, and user is able to provide 3000. Okay, let's test it, the data, and this data will fail. This code will fail. Why? Because in our list, we don't have enough data. We don't have this index data in our application, and that's why it is throwing exception. So you see, exception unhandled, system argument out of range exception. So you see, when you design your application, you should take into account that you have happy path, but you also have multiple failed paths, and you should handle these failed paths in your applications also. Okay, let me show you one simple example here. I'm going to design something better. So we have public class here, and I have public class customer. Okay, in my bank, I have customers. So let's just do it. Public string name. That's good. Okay, and I have private list of customers in my bank. Customers. Okay, customers. And let's construct our customers with some fake data. Add new customer. ID 1, name equal to customer 1, and let's just copy it. Oops, let's wait, and paste customer 2, ID 2, great. And I have one simple function called get customer by ID. Customer, get customer by ID. Okay, and I'm providing ID, and I will use our customer that first. I'm using first. Okay, and ID to ID. Okay, you may ask that, okay, let's use first or default, but let's say we are using our first. This is our internal algorithm, internal implementation. Okay, and I am constructing our bank. This is our bank. Okay, and let's call get by ID. I'm providing 4, and we don't have this customer, and that's why I'm getting error. I'm getting exception. In case of error, our C# application will throw exception. Okay, in case of error. So you should design your algorithm to handle this type of errors. In my case, it throws completely different exception. Long story short, when you define your algorithm, a customer may use your algorithm with unexpected data and may get some exceptions depending from your algorithm. And that's the beauty of C# exceptions. And now we'll talk about how to handle these exceptions in our application. But how to handle this type of exceptions in our application? Of course, providing such type of exceptions directly to user is not a good idea, and you may have some handling mechanism for your exceptions. First, let's just simplify our initialization process here. That's good. And let's go to our application. And in our application, I know that my application will throw exception here, may throw exception here. And that's why I'm typing try construction here. So try means try to run this code. And in case of exception, depending from your exception, in case of exception, just type that console.writeLine exception happened. Okay, exception happened. Great, let me just remove this one, replace it with readline. Let's run our application and wait for it. And here we are, exception happened. And it means now our application will not throw some sort of exception because we are swallowing, we are catching this exception and providing appropriate data to our user. But this is a general exception handling mechanism, and of course this is not a good idea because a user should understand that something is wrong, but having such type of general information doesn't provide any data for our customers, for our users. That's why if you want to differentiate the type of exception, for example, get customer by ID may throw multiple exceptions. That's completely okay. And you are able to catch this exception. One way of catching this exception is actually using exception exp mechanism, and it indicates that all type of exceptions will be handled in our catch. Why? Because, for example, let's say our get customer by ID will throw argument null exception, okay? And this argument null exception inherits indirectly from exception. So you see argument null exception inherits from argument exception. Let's go for argument exception. It inherits from system exception. Let's go to system exception. It inherits from exception. That's why to handle all type of exceptions in your application, you are able to use your just exception based class. And if you want to provide exact message in our exception, we have x.message, and that's how we are providing the proper message to our customer. So you see the sequence contains no matching element. Of course, that's also not a good idea. This is a technical implementation, so user will not understand what's the purpose of this message, what is a sequence. User even doesn't know about the sequential mechanism in our application. So it would be better to provide the appropriate information, the valuable information to our customer. Okay, and I will handle it here with you, but let's just focus our implementation. Right now I'm just going to remove our try catch right now. Okay, and let's allow our application to throw exception. So let's wait, run, and here we are. It is system invalid operation exception, and it means I am able to catch this invalid operation exception here. So let's provide invalid operation exception. That's good. So in case of to use exception in your catch, you should use the exact exception class, because this exception class will provide more information, and it means you are catching the exact exception, not all type of exceptions. If you provide exception here, it means, say we have in our method we have 4 exception cases, and this exception will handle all possible exceptions. But what if I want to handle only invalid operation exception? That's why I'm providing invalid operation exception here. So we have inheritance. It means we have dot message here. Let's run our application. We'll get the same message. There is no difference. But if in your application you have multiple exceptions and you want to catch your invalid operation exception, then you are able to provide another catch mechanism here to generally catch your exceptions. Okay, so it means I am catching my invalid operation exception. I am logging. In most cases, when we catch our exceptions, we are logging our exception, and we may provide completely different throwing mechanism, completely different message to the above layer. I will show you this mechanism also. So we are logging and we are writing our message, and if our application throws completely different exception, system will go to this catch, and this catch will catch all type of exceptions. What if I want to provide my exception first and then invalid operation exception first? The second. This will not work because this exception will catch all type of exceptions, and this is something similar like this. So you have return value, and after return you are doing some sort of operation. Our code will not reach to this line because we already have return here, and it is approximately similar, typing exception general class first and then the concrete exception last. And you should always first prefer to add a concrete appropriate exception first, and at the end the general exception. Okay, that's good. And let's move forward. In our case, we have sequence message, and unfortunately it doesn't provide a valid information to our customer. That's why I'm going to catch my exception directly in my method. So you see, I'm catching it here, and let's catch we have invalid operation exception. I'm providing my invalid operation exception here, and let's just do in this way. So when we catch our invalid operation exception, I want to completely change my exception message. So I am throwing through new invalid operation exception with completely different message. We don't have ID equal to given ID, okay, for our customers. Okay, and let's just run our application and see what we are getting. So we don't have ID equal to 4 for our customers. If you want to completely change exception throwing mechanism, you can catch the by default exception and provide completely different exception. To throw exception, we are using the throw command. So we have tried to catch our exception with catch, try catch combination. You cannot use try without catch. You can use try with finally, but you cannot just use try something like this. You should always type finally or catch in this case. Okay, so I'm using my try catch. Right now, I'm catching our invalid operation exception, and I am providing completely different exception message here and throwing the same message again. If you have exception mechanism, you should throw exception inherited classes. It means you can throw exception here, you can throw invalid operation exception, or depending from your case, you can implement your own custom exceptions, which we are going to talk about in this tutorial also. Okay, so we have the invalid operation. I'm just using the same invalid operation exception to throw with different message, and now it is we have more understandable message for our customers. Let's talk about catch in more detail. We already know that when we specify our try and we want to catch some information, we should specify our catch. And we learned that it is, of course, possible for us to use catch without any exception message. So I'm just running this application. Let's add some breakpoint here. And let's add breakpoint here. Let's just run it again. Let's run our application, and here we are. And we are just specifying completely different exception. What's wrong with this catch mechanism? We are catching all type of exceptions, and it means we don't know the exact problem, but we are always throwing invalid operation exception. Is that correct? Of course not. The first method may throw completely different exception. Let's just go for the first. Go to definition, and let's just investigate what we may get at the end of this exception. So you see, this first may throw invalid operation exception, but also argument null exception. But in our case, we are just catching it. It means we have two possibilities in our case, but we are catching all these exceptions and throwing completely new invalid operation exception. It means at the end, when our application will throw argument null exception, we'll catch it and will throw invalid operation exception. Of course, that's not a correct approach, and it is always better to catch a concrete exception here. So for example, in my case, I have invalid operation exception. So you see, I'm not providing the name here for my class, and I'm just using it. The case here is if internally I am not planning to access the fields, the methods of this exception class, I can use it simply like this. So the first possibility of using catch is using it as is. The second version of catch is using with exception type of stuff like invalid operation exception. And the third mechanism here is you can of course specify this value, and if you want to access to the properties methods of this instance, you should specify the instance name here. Okay, instance. And of course, we have many interesting ways of using exception here. I'm just specifying my exception, and in our catch we have when. So you can use something like this: if x is invalid operation exception, then catch this. It means I'm catching my exception, but I'm adding additional filtration, additional constraint to check if this exception is invalid operation exception. So first, may throw argument null exception. Okay, let's go for it. Argument null exception, and I'm checking if we have exact exception that's in type of argument null exception, then let's catch it. So I'm just providing exception message here. Let's run and see how our application will react. So you see, we have properly try executed, but the catch will not be executed. Why? Because we are filtering our exception toward to argument null exception. But right now, our application is throwing invalid operation exception. But how to handle it? Of course, let's specify invalid operation exception, because in case of for, our application will throw invalid operation exception, and let's run it. And here we are. So you see, we are catching invalid operation exception. You cannot use catch without try, but you can use try without catch. Let me show you in a simple manner. So you have just catch, but it will fail. Why? Because we don't have root element, we don't have try here. But it is possible for us to use try without catch, but with a simple trick. Right now, this will not work. You should add at least finally, or just type catch for your try to work it properly. What does finally mean here? The final means if you have some resources to dispose, to close, to clear. It doesn't matter if something happened, if exception happened or not. At the end, if you need to do some operation, you should add your logic to finally. For example, let me show you one simple case here. We have working with file, and here I'm just accessing to some file. It may fail or it may work, but at the end I want to close my file, so I will type file.close in my finally, or I may add some logging, or depending our application, I may add some additional business logic to my finally. Okay, let's wrap it to a simple example. Right now I want to use file.openRead. Okay, this openRead will take information from file. For example, in my C, let's say I have qwerty.txt. Right now I don't have this file, so as you see, open file will return a file stream. Okay, fs, great. And we already know that for file stream, we can use close to dispose to completely remove our resource, to manage our resource. But before that, I want to do some additional operation. For example, fs that, I don't know, let's say I want to write data. So you see, I have write functionality. I need byte stream, offset, count. Okay. So this is my byte. Data is going to be new byte file stream length data 0 and my fs dot len, and let's convert it to integer. Great. And at the end we have close. Right now I don't have qwerty.txt, but let's run our application. You see, if I don't have cqwerty.txt, it will throw exception, and we have a really simple way of handling it. The classical way, let's say, I'm using our try. Okay, I'm just trying to use our file stream like this. Let's copy, paste. So I will move our file stream outside. Okay, and use this file stream. Great. And at the end, finally, it doesn't matter if I will get exception or not. I want to close my file stream. Okay, I can use something like this. If file stream is not null, let's close our file stream. So if in case of success, our application will close our file stream. In case of failure, our application will go to catch. Let's say this is our catch. Let's catch our general exception here. So let's just simply type console dot writeLine exception dot message, and let's add the proper breakpoints here and here also. Let's run our application and let's debug one by one. So you see here we should get exception. Let me continue, and here we are. So we should see could not find blah blah information, and this is going to be our safe handle exception blah blah. This is not important, and let's continue. You see, in case of failure, even we are here. If file stream is not null, our application will close our handler here. That's cool. Even if we have the proper data here and we are able to read our data, the system will come to the final section and will try to close our file stream, even if it is not closed properly. But the better way of handling this mechanism, of course, is to use the using statement. Let me just move it to the using statement. So using file stream, let's provide our open here. Great. And let's just remove the previous file stream and let's copy. And that's all. There is no need to type such type of long code lines here. Why? Because when we have using our application, our C# will automatically wrap this code into try catch, and will try dispose this file stream even exception happened. Okay, let's just build, rebuild. Let's just run our application. So you see it is throwing exception. That's completely okay. And let's open our .peek, JetBrains.peek. Great. Now let's open our folder bin debug.net 8. Let's open our .peek and let's move our DLL here, and let's just open our program main, and let's try to investigate what we are getting at the end when we use our using statement. Where is our using statement? Here inside our main method. So you see this is our main method, low level C#. And you see we have using statement, but instead of using, we have try finally. This is really important. Sorry, I said try catch. It was try finally. So in finally case, we are finally trying to dispose our file stream. That's why it is important to use using in your disposable objects. Now let's talk about built-in exception classes in C#. We already learned that all type of exceptions will inherit from our exception class. That's why you should provide catch exception at the end. It means if you have, for example, our first will throw invalid operation exception, I'm catching it before my general exception. Let's just remove this one from here. Okay, invalid operation exception. This is my operation exception, and I am catching our argument null exception here, and at the end I am catching our general exception. Okay, that's how you should properly design your try catch structure. And let's dive into details of architecture. In our case, in general, in above, we have exception general class, and we have two main child for our exception. We have system exception, we have application exception. Always prefer using application exception for your custom exceptions to differentiate it from system exceptions. Why we are using system exception? Actually, Microsoft is using system exception because all type of Microsoft's built-in exceptions will inherit from system exception. For example, you have argument exception, it inherits from system exception. It also inherits from exception. You have invalid operation exception, its parent is going to be system exception, and you have any other exceptions. And this hierarchy will continue down. For example, we have argument null exception. It is parent going to be our argument exception. Argument exception's parent is system exception. System exception's parent is our exception. That's why you should specify in your catch, if you have 1, 2, 3, 4 catches, you should provide them from down to up. Okay, first you should specify catch argument null exception, then catch argument exception, after that catch system exception, and at the end catch exception. Okay, so you have top to down hierarchy, but you have down to top catch mechanism. That's how we are defining. For example, let's say our argument null exception and invalid operation exception as our siblings. So you can specify first invalid operation exceptions, then argument null exception, or vice versa, you can specify argument null exception and invalid operation exception, then depending from your design, actually depending from you. But you should always prefer to type catch exception. If you are catching all general exceptions, you should specify it at the end. That's really important. Okay, let's go for argument null exception. So you see it inherits from argument exception. Let's go for argument exception. It inherits from system exception actually, and the system exception will inherit from our exception. Great. Let's talk about the properties of built-in exceptions provided by Microsoft. For example, in our exception, we have message. This message will store the exact error message. But if you want to learn more about the exception case, you can check the stack trace information. Let me show you this stuff in a simple manner. I'm just removing this one. Okay, and what I'm going to do, I'm just going to type console right line exception.message. So this exception will catch any type of exception, argument null exception, invalid operation exception, because it is going to be parent for all type of exceptions. So in this case, I'm throwing exception. So you see our application fails. Why? Because not all code paths return a value. It means when your application works in this way, you are returning, let's say the return will fail. So it should catch, but there is nothing to return. That's why I'm just simply throwing. I will show you why I'm typing through, not through the exact exception, but let's just focus our current stack trace information. And let me just specify stack trace information. Right now we are throwing exception and we will print stack trace information. Okay, let me just remove this catch, this try. Okay, and let's just simply run our application. And it should print more information about our exception. Okay, let's see. So you see we have through let's just wait, invalid operation exception. So in our application we are throwing invalid operation exception, and then we are calling our through. It means we are catching our exception, but then we are throwing. That's why it would be better just uncomment our try catch here. Great, let's run it. And here we are. Let's just wait for it, wait our message to be printed. Great. So you see we have system enumerable first and get customer by ID. So using stack trace information, you can track your exception. It means, for example, I have 3 methods and at the bottom I got exception, and stack trace information will help us to move forward till the problem and to define, to investigate the problem, to get exact information about our problem. Let me show you the stuff in a simple manner. I have public customer. Let's just do it like this. Come on, public customer, get customer. Okay, get customer. I'm providing my ID. I'm internally calling my return get customer by ID. So you see I have a wrapper over my get customer by ID. I'm using get customer and I'm calling my get customer, and it should call my get customer by ID. And let's run our application and let's throw exception. So you see I'm throwing exception and I'm getting the exact message, get customer by ID. Okay, why I'm getting the exact method? Because I have handled my exception directly in get customer by ID. But what if I'm not handling it here? Okay, I'm just simply providing my user of library, my current bank library, to catch exception. Okay, and here we'll catch our exception. We should get invalid operation exception, and let's print our stack trace data here. Okay, so not directly in my method, but outside when I call our method, I'm catching our stack trace data. Let's run it and wait for the result. And here we are. So you see now we have more information. Okay, so we have get customer information. We know that we get exception in our get customer, but this get customer calls get customer by ID, and the exact error lives inside get customer by ID. That's what Microsoft calls stack trace information. Okay. In this case, if you have sub methods in your application, stack trace will help you to trace in your methods and to reach to the destination of your problem. Great. And that's about our stack trace information. I guess mostly you will use your message and stack trace information. And also when we start to create our custom exceptions, we will delve into details of other properties of exception class. It is time to talk about custom exceptions. We'll first try to understand how to create custom exceptions, then we'll dive into details of when to create custom exceptions. Okay, I always prefer to have exceptions folder when I have special type of exceptions depending from my business. Okay, so I will have exceptions folder, and let's right click at class. And yeah, let's select the class because all exceptions are classes in our case. And I'm going to have customer not found exception. Why customer not found exception? Actually, it depends from your business. Right now, I'm working with bank and customer entity. So I think it would be good for me to have customer not found exception instead of throwing sequential exception like we did before. Now, you see, all type of exceptions will end with exception postfix. This is also by convention, and it is better to follow this convention. So let's have customer not found exception, hit OK. Let's make it public. In our diagram, we already learned that all type of exceptions, custom exceptions, should inherit from application exception. But no one blocks you to use system exception or exception. But for me, it is preferable to use application exception because Microsoft's built-in exceptions will actually inherits from system exception, and that's a better way of differentiating Microsoft's exception from your to have inheritance from application exception. Okay, I'm having application exception here, but again, it is up to you. In many cases, you may say that people just using exception, or you can, as I said, use system exception, which is not preferable. So you have two choices, using exception or application exception. I'm preferring to use application exception. Okay, great. Application exception, especially for business operations. Okay, if you have common exceptions for all your type of microservices, etc., it's totally okay to inherit from exception. Awesome. So in my case, I will have special message, of course. Let's provide our message. For example, I will have customer, we couldn't find customer for the given criteria or something like this. And if you want to assign message to the original exceptions message, unfortunately, having something like this will not help because our message is only for getter, and that's why you should call construction chaining here and base, I'm providing my message. That's all. But if you have a concrete message for all possible cases, and if you don't want to provide a message, you can just simply use something like this. We couldn't find a customer for the given criteria. Okay. Something like this. I hope that will help us to handle most cases. Great, cool. Let's just remove unnecessary usings here. And in my application, so you see here we are using first, and I'm typing try. Great. Let's catch our invalid operation exception. And for invalid operation exception, I'm just throwing new. What is our exception name? Customer not found. Great. Customer not found exception. Cool. You can use your exception as you use Microsoft's built-in exceptions. And I'm not providing any message. Okay. And let me just call my bank that get customer by ID, 100. And now let's run our application. I should get an exception here. So you see exceptions, customer not found exception. This is more meaningful rather than throwing invalid operation exception or sequence blah blah stuff. So this is always better to prefer custom based exceptions for your business operations. And this is really easy to implement your custom exceptions. But if you have any other data for your custom exceptions, you can easily provide it like this. Public, let's say boolean is font. Say we have get set by default. Let's make it true. And in case of is font, let's make it false. Okay, so you can provide something like this. This is of course not meaningful, but again, it is up to you to provide any data here. You can add any date time information, for example, to get the exact exception time. So I'm just providing date time, exception time here, get init, okay, and I'm using exception time, date time now, and let's just use exception time, for example, date time now. This is just a simple example of using any property you want depending from your application. And actually with your application you can provide more information. For example, when you inherit from exception, you will have some additional properties, and one of them is going to be your help link. If you are implementing some sort of library, for example, you have some sort of NuGet package or etc., and you want to specify a reference for your users to check about this error, you can provide help link. Okay, and this is something like this: https blah 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 blah, something like this. Okay, and this help link will help your users to get more information about your exception. Well, right now about stack trace information, I will not mention it. We have message information, and we have more properties here. For example, let's go for them. We have, for example, data. You can use this dictionary data information about your customer information. For example, I'm providing not just my customer not found information, but also integer ID. And let's take, for example, dictionary key is going to be our customer ID, and let's assign our ID. It means from the exception, I will be able to get my customer ID information. Okay, let me catch our exception here, try, and let's call our get customer by ID. And here, I'm not catching general exception. I'm catching our customer not found exception. Customer not found exception. Great. And for customer not found exception, I have data here. Okay, so this data is going to be dictionary. So I have keys, I have values here. For the data, I want to get my customer ID, and let's just simply write our customer ID. Okay, this is a secondary information. If you have something in your data, it means it is secondary mostly. For you have a message, but for the secondary information, you should first specify your ID here. Okay, let me just do it in this way. And this is our integer ID also. And let me just copy stuff. You can refactor it, but it is what it is for now. And let's provide our ID. Great. And I want to access to my customer ID. Let's run. And here we are, 100. You can get any information from your data. You should first set, and then you can get this data information. That's great. So this is how we are simply creating our custom exceptions. And when to use custom exceptions, of course, depending from your business. For example, depending from my business right now, I have customer and I am looking for a customer and I can get customer exceptions. So I'm providing customer not found exception to override Microsoft's built-in exceptions to make it more understandable for our user to track, to understand what happened when they provide the wrong data to our method. Before moving into best practices, I want to mention one fact related to through comment here. So you see we have invalid operation exception and I'm changing it to customer not found exception. It is possible for you to just throw invalid operation exception like this. And in most cases, you will be asked one simple question in your interview. It is about the differences between through and through your provided exception. It is not recommended to use through X. So first you may think that why I need to catch my exception and throw it again. Why I'm not just removing try catch and it will just throw the invalid operation exception. Yeah, it is correct. But if you want to do some logging, some non-related exception based operation, it is always preferable to catch your exception and throw it again. In my case, when I type through my exception, you see I'm getting some warning and it is about rethrowing. So you see rethrowing catch exception changes the stack information. The problem here is you will lose your stack trace information and it is not a best practice. It is always preferable to just type through and it will help you to throw the same exception but with stack trace information. So this is really important. Don't type through X or similar things like this. Prefer always use through. And the last in our tutorial is going to be best practices based on exceptions. In our application, we'll have some sort of simple hierarchy. So we have UI, we have business logic, we have data access, and we have domain models. And let's go to our application. This is our UI, which we are going to use our web API. You can use console application, WPF application, doesn't matter at the end, even API, MVC application, all of them going to be your UI. And we have services. We'll implement some service operations here. These are the data access domain services are going to be our class libraries. And this is our web API. Okay, I will start with our domain model. So right click, add class, and I will have account here. Okay, this is going to be my domain model. So I'm providing them public. This is my record. Okay, if you want to learn more about records and if you want to understand why I'm using records here, just check my records tutorial and you will understand everything related to records. Okay, so I will have some public get init my ID. I will have get, so we will have the account name and the most important stuff here, our account number. So this is going to be our account number. Okay, and let's from the constructor build our data. I will use GUID here. Okay, GUID information, and I will instantiate it something like this. GUID.new GUID will have the string name. Okay, let's use string name and string account number. Let's go for it. Name and account number. Great. In our domain model, we need to use exceptions. It is, of course, preferable to use exceptions because your domain model is going to be your source of truth, your main stuff in your business, and it shouldn't allow to have invalid state. So your domain model should always be in a valid state. That's why it is preferable to use exceptions, but it is up to you. You can use the result stuff, railway oriented programming. We'll talk about it. But for now, we are going to use our exceptions. So I'm going to have a separate folder New project. This is our separate class. So this is our xapp.common. In my application, I can use this common library. Okay. And I always prefer having something like this. And this is my exceptions. You may have the exceptions, extensions, I don't know, all the common stuff in your command. This is some sort of a share it. Okay. And what we need to have some sort of validation here. Okay. And right click, add class and validation exception. This is our validation exception. And let's inherit from application exception. Okay. And let's construct our validation exception string message. For now, I think having just simple message will be enough. Depending your requirements, you may have multiple constructors, and having one constructor in my case doesn't mean that it is a de facto creation for your custom exceptions. Okay. Right now, I need only one constructor here. Great. And what I want to do, I want to validate my data. What I can do here, I will have something like this. If string is null or empty, then let's throw our validation exception. Validation exception. Okay. We need to have a reference to our library. Let's go to our domain, right click, add. This is our common, and let's add it. And here it is. This is our validation exception. So you see, right now in my application, I have only one account, but I may have multiple domain models. I will have multiple domain models. And every time just typing something like this, checking length, checking the negative, positive values, etc. This type of stuff is going to be a little bit annoying for me. And every time typing if throw is not a good idea. So I'm going to have special validation mechanism. And this is my, of course, extension methods. Okay. If you want to learn more about extensions, just check my extensions tutorial to learn more, to learn how professionals use extension methods in their practice. So I'm going to right click in my command, right click, add folder extensions. Okay. And right click, add class validation extensions. Great. This is our public static, and to not to instantiate every time our validator, I'm going to have private static validation exception. Okay. I will not use system components validation exception, but mine, and is just validate string message return, just through new validation exception. This is our validation exception, and just validation message. This is my validation message. That's good. Through validation. Great. And let's have our extension methods. Okay. Public static validation exception is not null or empty. So I'm going to have this. This is my T model. So I will use T model here because I may use this validation for any type of data, but preferably right now I will use it for my string. So I'm going to type this string, my model. Okay. And if string is null or empty, let's just call our through validation let's return it through validation, and let's data is null or empty. Okay, and let's just return our model, simply our model. Okay, string. Through validation exception, and that's all. So in case of any fail, in case of null or empty, we are throwing our validation exception, and otherwise we are returning our data. Cool. And I'm just going to have something like this. Let's remove it. And we have reference to common, and I'm adding dot and is null or empty. Okay, let's use is null or empty. This is our extension method. Let's just add our namespace using xapp, common, extensions, and here we are. This is our is not null or empty. And the same is applicable for our account number. It is valid account number. Okay. We'll check if this account number is valid or not. I'm just going to have it something like this. Is valid account number. This is our common library, and having such type of domain model dependent validation, of course, is not a good idea. So you should provide a common validation to make it reusable, to use it in your different projects. That's why I'm just typing is in valid range. Okay, is in valid range. Oops. Is in valid range. The valid range should be 4 and between 4 and 10. Okay, and int min, int max. That's how we are dealing with this value. So our account number should be between 4 and 10 symbol. And let's just model it. This is our this string model. And if our model.len is greater or equal 4 and model.len is less or equal to 10, then let's return our model. Otherwise, let's throw exception. Okay, and let me just copy the name, paste it here, and let's provide our 4, 10. That's great. So you see how we are handling our exceptions in our domain layer. It is always best practice. It is always good to have the exception throwing mechanism in your domain models. Of course, many people will use this variation of exception, but some of them may use the result pattern based mechanism. It is also okay, but in most cases, we are using exception mechanism. Okay. Cool, and I think for now, that's all. Let me just remove unused namespaces. And let's go to our data access layer. In our data access, I have simple repository stuff. This is my account repository, okay? And for the account repository, I'm not going to use interface or etc. type of stuff. I'm just going to provide public account get account by ID and int account ID. So what do you think about this? So I'm just going to add reference to my data access domain. Great. And let's add our domain model here. So in case of exception here in your repository layer for getting, it is not a good choice because you may get account or you may not get account. That's why we prefer to use nullable mechanism, and it has clear declaration in our method that we are accepting account ID and we are returning account or we are returning nullable information. That's why it is not a better choice for repositories, for services to throw exception. It is costable operation. Of course, it has stack trace information. I have a separate tutorial to check the differences between exceptions and result pattern. Just check it. But for now, just understand that throwing exceptions in your repositories, in your services is not a good idea. In your domain models, everything is quite good. But for your repositories, for your services, it is not a good idea. For your repositories, you may have some exceptions, of course, but they should be unexpected exceptions. Okay, you are expecting in my case, I am expecting my user to provide some account ID which doesn't exist in our database. That's completely okay. And throwing exception in this case is not correct because this is expected case. You should throw exception for your unexpected cases. For example, when dealing with entity framework, for example, there is no connection or some unexpected stuff happened. Yes, that's completely okay to throw exception, but for expected cases, it is not preferable to throw exception. In my case, having account ID, for example, we have three account ID 1, 2, 3, but user provided 10, and I'm expecting my user to provide some value which doesn't exist in our database. So it is expected case, not unexpected case. That's why you shouldn't throw exception. Just having some type of signature like this will be completely enough. Okay, let me just simply return new account here. This is my account. Let's say the name, and this is my account information. That's good. That's great. Okay. I'm just simulating our repository stuff here because implementation is not important. We're just talking about expected, unexpected cases. We are trying to differentiate when to use exceptions, when not to use exceptions. If you want to use exceptions, just remember that it is okay to have exceptions in your domain model when you use domain-driven design. And also, if you have unexpected cases for your layers, for example, in our data access layer, we are dealing with entity framework, we have some sort of exception here when we work with entity framework or other type of stuff. In case of unexpected error, you should throw exception. Otherwise, for expected cases, you shouldn't throw exception. Great. And now let's switch to our services. Let me just right click, add our class, and this is going to be our account service. Okay, and my account service will encapsulate the work with the repository, account repository. Let's go to the right click, add project, and data access. Okay, account repository. Oops. Account repository. Let's add reference. Okay, this is my account repository. Instead of dependency injection, I am using something like this, and public account get account by ID, which is going to be a wrapper over our repositories account ID functionality. And what I want to do, account repository get account by ID. Okay, and in account, and if account is null, through new account not found exception. So we couldn't find account information, otherwise return account. So what do you think about this implementation? This is similar like our repository. We are expecting for our user to provide invalid data. So this is expected case, okay? Not unexpected case. You should throw exception only for unexpected cases, and in most cases it indicates for bug, it indicates for critical error in your application. But right now I don't see any critical stuff here, and it is not a good choice to throw exception. If in your services layer you have some logic like this, you should definitely remove it and use completely different approach, which I'm going to show you right now. Okay, and let's just remove it, and I will use result pattern railway oriented programming. Just check my railway oriented programming tutorial where I have explained it at the result pattern and all the things related to result pattern. So I'm just going to use tools, NuGet package manager console. Okay, and let's install package. I really love to use C#, functional extensions library. Okay, let's hit enter, and here we are. Sorry, we have installed it in a wrong library. Let's select our XApp services. Let's install C# functional extensions. That's great. And I'm going to return error message or account information to my upper layer, to my UI layer. That's why I'm providing a result here, and I will have string message. For now, for the simplicity, I'm using string message, or you can use the enum stuff, or you can wrap it to a class, something like domain error class, to provide more information about error for your customers. Right now, that should be enough for me. And what I'm going to do, the account is null. If we don't have account, let's return result dot failure, and let's provide our account, our string, and we couldn't find account information you provided, otherwise result dot success account string, and let's return our account. That's how you should design your libraries. If you have unexpected cases, just throw exception. For your domains in your domain-driven design, for your rich domain models, that's totally okay to have exceptions. And in your services, if you have in your repository services, if you have expected cases, some sort of validation, etc., don't throw exception, just use result pattern railway oriented programming in this case. And let me show you how to handle this service layer implementation. So I'm going to right click, add, this is our services domain. Let's add them. Great. And let's go to our controller. For example, I will have completely separate controller. Let's add from the API. Let's select our API controller. This is going to be our accounts controller. Great. We have route, API, and controller base class. And this is my HTTP GET. Let me provide our ID here, and public action result account and get account by ID, integer ID. Let's from constructor get our service private account service, and this is read only account service. So you see, we have in our services, we have account service. I guess it is not public. That's why we can't see it here. Account service using XApp services. This is our account service, and let's instantiate. Just use dependency injection in this case, but for simplicity, we are using just direct initialization stuff. Get account, okay, and var account. Now we have, you see, we have C# functional extensions or result, and it indicates that you can check something like this. If is success, if everything is okay, you can return your account.value. Otherwise, else, or the else means your account.failure is failure, okay? Otherwise, just return bad request with account.error message, something like this. That's how we are interacting with exceptions and result-based mechanisms. You should use result-based mechanisms always if you have expected cases and you're able to handle them using is success or is failure from your higher layer, okay? Well, I think that's all. If you like my videos, please don't forget to subscribe, hit like button, share, and I'll see you in the next tutorials.